In this problem, we're asked to find the symbolic representation for the inverse of this function. So our function is x squared minus 2, and notice since it's quadratic, it's not 1-to-1, and that's why we have this little restriction on the side that says x has to be greater than or equal to 0. That would only give us one side of the parabola, and which would be 1-to-1. So following the steps to find the symbolic representation of the inverse, the first thing we're going to do is replace f of x with y, not a big deal, and then copy the rest of the problem. Now we switch our x and y. That is, everywhere there's a y, we put an x, and everywhere there's an x, we put a y. Those steps are the same in every problem, but now the resulting problem, we need to solve it for y. We want to get y by itself. That's the part that varies from problem to problem. So in this case, I'm going to move the 2 away from the y squared by adding 2. That'll get me x plus 2 on the one side. I'm also going to turn this around so that my y that I'm solving for is on the left. So y squared equals x plus 2. And then I isolate the y from the square by square rooting both sides of the equation, but I have to remember that that gives me both the positive and the negative square root of x plus 2. And this is where we go back to the fact that x is greater than or equal to 0, and thinking about that parabola that I talked about earlier, that would mean the right side of the parabola. So in this case, that means we're going to grab the positive square root of its inverse. So positive, I'm going to write it to emphasize, square root of x plus 2. If the original restriction had been x is less than or equal to 0, then we would have taken the negative side of that. And then one final little step is to replace y with the symbol for inverse, f inverse x, with that little -1 exponent. It's not an exponent, it goes with the function, and that would equal positive square root of x plus 2. But now this resulting function, the inverse function, also has a restriction on its domain, because we know that x plus 2 has to be greater than or equal to 0 in order for that function to be defined. So x has to be greater than or equal to -2. Or in interval notation, that would be a bracket, -2, comma, infinity.